the basic operation here. This is your main power.
Excuse me. Yeah, there's some lights in channel 4 and everything.
Oh, yeah. Okay.
Okay, so the first thing is to hit the main power. This is a sluggish little neon bulb. So this is each phase, 220, this is each phase. Because half the phases, one phase to neutral runs that system 120 volts, the other phase runs all the little doodad. So this gives you both phases. Here's your variac, and that variac gives you, there's your voltage. So you're coming through there. You don't have to crank this all the way open because it runs good at about 100 volts, 112 volts or something. You don't have to zip it all the way up. It's not necessary. But it gives you the leeway to use this thing at a lot of various powers so that you can research and experiment and do stuff with it. It makes it safe. Otherwise, if you just run it, you know, a lot of them are built so they just run up high power. You've got to be careful because it's just, well, we'll talk about that. Okay. Now, you have current and voltage. This is here to show you what the current is. You're going to see this thing rocking up because it's going to charge and discharge, and the capacitors are going to, you're going to see a fluctuation, and you're going to see the current rise. You know, for a steady current, you don't want to run more than about 30 amps, 35 amps, but don't worry about reading that. It's just something you can see, and you can show people how it draws current. You can explain a lot of that. Okay, now, we have a safety feature here. And the safety feature, main safety feature, this is not to turn the variac up and crank it on and run it. Don't do that. This is so that when you're going to run this thing, you turn on the rotary spark gap, we'll get to that in a minute, and then before you're ready to start, this is the last safety feature, this is two relays in there that disconnect the main power from the unit, so that under no circumstances are you going to get, you're going to screw up in here with this. You're not, in other words, this is a safety feature that once this is actuated, you're connected to the main power supply here. And at that point, you know, you run the risk of there's current going to be going through here, the system's going to be working at some level or not. But when you're using a discharge stand or anything like that, at any time that there should ever be any difficulty where instead of having to crank this down or whatever, you do one thing, boom, just like that, and that shuts the whole thing right down. That's what that's there for. There is a fuse here that covers that circuit, so that you know, any time that doesn't work, it's probably the fuse. There's a fuse in there that tells you that that circuit could be blown. Over here, there's also a fuse that's across the rotary spark gap primary circuit, and inside there's a fuse that goes from the secondary of right here is a variac. Now, that variac is set to a certain speed to operate this coil. If at some point, I don't recommend this, but when you get familiar with the Tesla coil and you fool with it and stuff like that, you can we'll show you this. You can open up the back and you can adjust the speed of that rotary spark gap. You can turn it up, you can turn it down, but it's running now about 2,400 RPMs or something. That's pretty fast, and you don't really need to fool with that. But something you can change the tune of it, little like, you know, but that's not necessary. That's set to run at a pretty good optimal rate right now, and all you have to do to get that thing to run is just hit and you'll hear it. And that's an important thing to hear. You must have that running. If you run it without that, you're going to cause problems with it. It has to be running, okay? So that's how that works. Then, and of course I have them, this is the relay. I have main power, and get the phases. Relay is here. XFR means transformer. This is what the transformer is drawing through the system. It shows you here. Actually, both of these are set. One is set after the variac. This is set before the variac, so you can see the main power flow that runs through the system. It shows you here. But don't worry about that. That's more for, well, you can teach and show how current is drawn when you add voltage to an inductor around that coil. As the voltage goes up, then it starts to draw more current as the magnetic lines of flux get more powerful, and you start to push to the secondary, you draw power. That's how that works. So you have this RSPG, rotary spark gap, what that stands for. 0 to 12, this is only a reference. It means nothing. This is what you're looking at here. It's just 0 to 12 because you might say, well, for experiment C, we set it to 4 and run it. For experiment D, we set it to 10 and run it. For the other experiment, we set it to 2 and run it. That's that's on there for your own particular purpose. You can see where the knob pointer actually gets to. Okay, so that essentially is how you do it. Now, here's the thing, running a Tesla coil. Okay, 15 seconds at a shot. Run it 15, turn it down, because there's a tremendous amount of stress and strain running in there. And of course, 15 seconds, 10 to 15 seconds shot of a spark is going to have people really, they're going to want to have a little rest and catch their breath and turn it back up again. Don't crank it all the way up and let it run for a couple minutes, because you definitely will stress it out. You don't want to do that. You just want to give it, and that will, it'll last forever that way. So this is how you want to do this, and this sets this thing up perfectly. So I'll run it once, and you can see, once you cut that light, and we'll run it a couple of times here.
When we start out. Real good connection. Yeah, I went through this yesterday. Stand right in that, and then move your feet around and do your.
Is it mixed in there?
Yep.
I'm not gonna die, right?
Nope.
You got them, Mr. Deeds?
Yep.
Mom, I want $1 million if I die. You get it.
Just step right in the center. Now, the sensation that you're gonna feel is gonna be at your ankles. Okay? Now, I don't know how to describe the sensation to you. It's not electrical shock, it's just a sensation. Now, I'll be starting out at very low amounts, and then whenever you get to the point where you don't want any more, you can say so.
Okay.
And it varies from one person to another. Like, I take a pretty high amount, and it doesn't really bother me that much. Maybe it'll bother you, and you won't be able to take as much, or maybe it'll be less. But the first thing that we'll do is you will hold these like this with the tips, like just above your head.
Apart?
Yep. And then, if the sensation becomes more than you care, or seems like a little too much, just bend your knee, because what it is, we get a real good discharge to this pipe, to the ceiling, if you bend your knees a little bit up and down.
Let's see, let me close this door over here so that when
First they go out